Back in the 1980s, the already robust mechanization, which has taken a leap, accelerated multiple times with the advent of digitalized technology. Now the analog transformed into digital and the impacts that humans were playing in the industries reduced to a minimum. Robotics, telecommunication, transportation, and connectivity reached to its zenith in history, where nobody had previously experienced such a grand leap. Every discipline saw a massive progress, but the advancement in physics and computing grew exponentially. This robust change in physics and computing technology made crucial advancements in other fields as well, especially biotechnology, pharmacy, bioinformatics and nanotechnology. In today's video we will be focusing on Anther flagship progress in science, especially in the field of nanotechnology, and we will discuss the applications of nanotechnology in the later part of the video. You all know we upload very informative videos regarding innovative technologies and other topic of your concern. Show your love by like, subscribe and sharing the video as much as we can. Press the bell icon if you want to get the update of our each and every notification. Before getting any late, let's start the video. So let's first focus on what nanotechnology is. Building things on the size of atoms and molecules is the focus of the study and innovation area of nanotechnology. These things are often materials and electronics. 1/1,000,000th of a meter, or 10 times the diameter of a hydrogen atom, is a nanometer. And typical human hair measures 80,000 nanometers in diameter. The standard laws of physics and chemistry no longer hold true at such sizes. For instance, there can be significant differences in a material's properties between the nanoscale and the macroscale, such as color, strength, conductivity, and reactivity. Carbon nanotubes are 6 times lighter and 100 times stronger than steel. In other, nanotechnology refers to those branches of science and engineering that make use of nanoscale phenomena in the creation, characterization, manufacturing, and use of new materials, structures, devices, and systems. Although there are numerous examples of structures with nanometer dimensions, also known as the nanoscale, in the natural world, including vital molecules found in the human body and elements of food, and although many technologies have unintentionally used nanoscale structures for many years, it has only been possible to actively and intentionally modify molecules and structures within this size range in the last 25 years. The characteristic that sets nanotechnology apart from other fields is this control at the nanometer scale. It is obvious that the numerous applications of nanotechnology have the potential to have a profound influence on society. In general, it is reasonable to predict that the use of nanotechnology will be highly advantageous to both people and organizations. Numerous of these applications involve new materials that operate at the nanoscale, where novel phenomena are connected to the extremely high surface area to volume ratios experienced at these dimensions, as well as with quantum effects that are not observed at larger sizes. These materials offer radically different properties. These materials come in the form of extremely thin films that are utilized in electronics and catalysis, two-dimensional nanotubes and nanowires for optical and magnetic systems, as well as nanoparticles that are used in coatings, cosmetics, and medicinal products. Scientists can now analyze items on a much smaller scale because of the development of nanotechnology. They thus need a unit of measurement that corresponds to this size, which they call the nanometer. A nanometer is 1/1,000,000th of a meter in size. You may see the nanometer as being 100,000 times smaller than the width of a human hair, or the thickness of a sheet of journal paper. Nanotechnology can be seen in nature in several instances. For instance, frogs measure deflections using the nanomechanical cantilevers found in their ears. They can quantify deflation as tiny as 3 nanometers based on the sound they hear. Additionally, nanoparticles that function as photonic crystals give butterfly wings their richly colored appearance. Additionally, nanotechnology can make our lives healthier and more productive. It has the secret to supplying renewable energy to satisfy global demand. Additionally, it may filter contaminated water to provide us access to clean water sources. As it has several uses in the medical industry, it aids in maintaining human health. It could include suggestions for increasing the yield of agricultural crops. Additionally, it makes a significant contribution to the advancement of technology. So dear viewers, as far as nanomaterial is concerned, there are various classifications of nanomaterial. According on how many dimensions are larger than the nanoscale, 100 nanometers, nanomaterials are categorized. They are so classified into zero-dimensional nanomaterials. Nanomaterials with zero dimensions include those that are 100 nanometers or less in size, such quantum dots, which are employed in transistors and solar cells. One-dimensional nanomaterials. These substances, which are larger than 100 nanometers in size and of just one dimension, include nanotubes, which are crucial in the production of electronics. They are utilized in surface coatings, such as those used to protect metal objects from rust and corrosion. Additionally, they protect food against decay and infection. Two-dimensional nanomaterials, such as nanolayers, are employed in the production of sensors because they have two dimensions that are not nanoscale, less than 100 nanometers. Three-dimensional nanomaterials. Although certain materials have all three dimensions larger than 100 nanometers, they are nonetheless categorized as nanomaterials. This categorization was made as a result of the material's possession of certain nanoscale traits, such as a nanocrystal structure or the presence of other materials that are 0, 1, or two-dimensional nanomaterials. Nanoparticles, powder metallurgy, and highly soft ceramic materials are a few examples of such. It should be emphasized that due to their wide range of technical applications, three-dimensional nanoparticles are the most widely manufactured form of nanomaterials worldwide. So let's see what nanotechnology can do and what its applications are in the world of technology. Nanotechnology is touted as having the ability to improve energy efficiency, aid in environmental cleanup, and address significant health issues. It is said to be able to drastically cut expenses while greatly increasing industrial output. According to proponents of nanotechnology, products will be more useful while being smaller, cheaper, and lighter, and will take less energy and raw resources to produce. Some materials may be changed at the atomic level to give them distinctive and significant visual, electrical, or magnetic qualities. This is why diverse fields of life, like energy, health, agriculture, electronics, etc., have distinct uses for nanotechnology. We'll now discuss a few of these applications. 1. Tiny doctors inside the body. In recent years, there have been significant advances in the application of nanotechnology in medicine. The use of nanomaterials for the diagnosis and treatment of illness is the subject of massive amounts of research funding. For instance, by developing nanomaterials containing fluorescent dyes that can attach to the illness-causing chemicals in the blood, we have achieved significant progress in the field of disease detection. 2. Nano boots and teeth. Nanodentistry is a revolutionary new technique that has advanced dentistry significantly via the use of nanotechnology. There are a number of innovative dental goods on the market that make use of this technology, from implants to oral hygiene items. Oral and dental disorders are diagnosed, treated, and prevented with the help of nanodentistry. Additionally, it is employed to lessen discomfort and enhance tooth wellness. Nanoimpressions, nanoceramics, nanocomposites, and nanofillers, to mention a few, are already being produced by businesses. The use of nanodentistry in the treatment of oral cancer has the potential to advance medical research if it is effectively developed. 3. The creation of graphene. Utilizing graphene and other supermaterials with passive nanostructures is a potential new use for nanoscience. A single sheet of carbon that is one atom thick makes up the nanomaterial known as graphene. It is very tough and exhibits promising electrical conductivity qualities. 4. Electronic sensors. The current state of nanotechnology allows for the printing of sensors with incredibly minute characteristics on flexible rolls of plastic. They are inexpensive to produce in big quantities. Critical infrastructure, including bridges, aeroplanes, nuclear power plants, and other structures, may be continually monitored for health using these sensors. 5. Self-heating. Although most people still think of self-healing as science fiction, this will likely change as nanoscience develops further. Certain materials can acquire some extremely intriguing features by having their atomic structure altered. For instance, a number of commercially accessible materials currently feature special atomic textures that enable them to repel water. 6. Possibilities in big data. The massive growth of electronic data in our information technology era has created an urgent need to handle this data properly, identify trends, and warn us of issues without losing crucial information. For instance, leveraging big data from traffic sensors to regulate traffic and prevent accidents, preventing crimes by more wisely allocating police resources, and many more. 7. Fight against climate change. Finding new and more efficient ways to generate power is one of the most important things we can do to combat climate change. Nanotechnology advancements have already led to batteries for electric automobiles that can store more energy and solar panels that can more effectively turn sunlight into power. Nanotexturing is used in each of these applications to transform a flat surface into a 3D one with a significantly larger surface area. Greater energy storage or generation is made possible by giving reactions greater room to occur. So this was all about nanotechnology and its applications. I hope you liked the video. Tell in comment section, have you ever come across nanomaterials, and how you feel about this technology.